Okay, I think we can go ahead and get started. So my name is Jennifer Hickey, and I'm here with Ramnivas Laddad to talk to you about what's new in Cloud Foundry. And just to give you a little bit of background on me, I'm an engineer on the Cloud Foundry team, as is Ramnivas. We're specifically focused on support for the various frameworks that Cloud Foundry provides, but we're here to talk to you about pretty much what's new across the Cloud Foundry landscape. I've been with SpringSource for a long time now, I think 5 years or so been at every SpringOne. I'm actually getting proud of that with however many years we have, my streak. So before we get started, I just want to kind of find out where you guys are at with what you're working on and if you're familiar. So the first question is everybody familiar with Cloud Foundry? Either went to a boot camp or has used it? Raise your hands if you know Cloud Foundry. If you've seen it before, pretty in-depth. Okay. That's most everybody. We'll do just like a 2-minute intro for those who aren't familiar so that you can get up to speed as we go. And then I guess how many are Spring developers here? Good. Okay, the majority of the room. Do we have any Ruby users? Okay. Yeah, we guessed right on that one. What about Node.js? Anybody using Node right now? Okay, we do have a Node user back there. Okay, that'll just kind of help us see where to focus on some of the new things that we're going to be talking about today. So with that, I'm going to go ahead and ask Ramnivas to come up and get you started with the talk.
So a bit about me. I'm also a long-time SpringSource sourcer. I think I missed one SpringOne conference for some personal reasons. I'm author of AspectJ in Action. That's that is my passion, one of the passions. And currently I'm focusing on cloud computing as well as Scala and functional programming. So Cloud Foundry, those who are not very familiar, is an open PaaS. What it means is it's a platform as a service, and specifically application platform as a service. So as in, rather than thinking about virtual machines or thinking about infrastructure, you focus on your application and everything else. Your services, compute power, storage, all those things are provided by a platform. So in Cloud Foundry, we also have triangle. Yesterday night, if you attended a keynote, there is a Spring triangle, and we also got one. Inverted one, but nevertheless a triangle. So at the top, we have languages and frameworks we support. So we support Spring, Grails, Java, but we also support Scala, and something that Jennifer will talk about later. And we also support languages such as Ruby and Node.js. On the application services side, we support pretty much every imaginable service. So we have data services, relational databases, MongoDB, etc. We have also messaging services, RabbitMQ, and other services that either we will provide or third parties can add. The final part, and that's where the openness comes in a big way, is we have cloud provider interface. As in, CloudFoundry.com is one instantiation of Cloud Foundry. So you can think of Cloud Foundry as a Linux, and then you can run Linux on a particular hardware just fine. So similarly, Cloud Foundry can be run on VMware's hardware and virtualization, but also other virtualization techniques. Or even on your laptop, that's the micro Cloud Foundry. So Cloud Foundry has turned one. In fact, this happened in April. And at that time, we announced that we open source one last piece that we hadn't earlier. We take openness message pretty to our heart. So we want to give you all the capabilities to create your own cloud in your data center, for example, and be able to essentially do what we do in CloudFoundry.com. So one of the big pieces is BOSH, which allows you to deploy and update cloud at cloud scale. So you can have thousands of virtual machines, and you can do updates without any downtime. And we also have a new open source contribution process. So initially we had a process, but it was a little bit awkward to contribute, and now we have a very straightforward process. That's the process we follow. So if we want to, let's say, change some code, then we submit get it reviews, and committers then review the code and give you +1 or -1 or +2, some rights that let you essentially push your commit. And we have more partners because Cloud Foundry, we look at it as an ecosystem. So we want more partners to join and help us make it better. So what did we do since last SpringOne? So these are the major themes that we worked on. So one of the big one is solid foundation. We launched about a year and a half back, and from that day we never had really a good any significant downtime. But we looked upon, we examined what we could do better, and we changed our architecture for most components to make it even more resilient to failures and easy to update and performant. And we will talk about those, Jennifer will discuss those later. We also want to have diversity of applications. So initially at the launch, we focused on web applications, and with some languages, Java mainly, but also Rails, Ruby Rails and Node.js. But then that's not the world it's comprised of. There are other languages and other frameworks that we need to support. So what we did is we supported Scala this year in a big way. So we have Play framework, and we can run Akka applications. And we also did a sort of catch-all framework, standalone applications. So you can bring your own container. You can run non-web applications just fine on Cloud Foundry. And in fact, this opens up all kinds of interesting possibilities and architecture styles. We wanted to make things easy. So we spent good amount of time on improving our tools, PMC and STS, to make it very easy for you to push your application, change its properties such as scaling. That's one side. On the other side, we also improved our runtime support. So auto-reconfiguration, we made it available for all the services and for all languages. So earlier when we started, we had only for Spring and Grails. But then we made it available for Ruby Rails and Node.js and Play framework. Everything basically essentially enjoys same easy. So essentially you take your application, push it, and as long as your application is sort of falls in a fairly wide range of typical application, it just works. And distributed applications. So you will see this theme throughout SpringOne, that applications are no longer monolithic. So you want a web application and maybe supported by some background processes, maybe some batch applications. We want to support this possibility. In fact, Cloud Foundry itself is a distributed application. And so for that, we added support so that it will become easier for you to really create, and Standalone is one part of it, to allow you to do distributed applications. And finally, we want to make it enterprise ready. So one of the questions that we get asked all the time is, okay, there's a cloudfoundry.com, it's in beta. When is it going to get out of beta? We are now getting very close to offering that possibility. So you can pay, and we will happy to take your money. And in return, we'll provide you more capabilities, more memory, more services, more tiers of services. So you can say, okay, I want to have gigs and gigs of memory. Fine. As long as you're ready to pay, we're ready to offer you that. So for that, and there are some other aspects to it, such as better process isolation and other things. So we are keeping so that enterprise can feel comfortable pushing their application to Cloud Foundry and make it run there. With that, I will hand over back to Jennifer.
Okay, so actually before we get into the agenda, I'm going to do the quick intro that I promised you guys, just to push a hello world real quick. And this is actually kind of the super secret way to win a hoodie at the booth, so you guys might want to pay attention if you haven't done so already. So I'm just going to use STS, and we're going to create a new template project. So STS ships with a number of template projects here. We're going to go with a Spring MVC project. Okay, we'll call it Hello World. And let's give it a package structure. Okay. And we're going to ignore Maven complaining about it. Let me get it visible real quick. Okay, so here's our hello world. If we look at what we actually got created from STS, it's just a simple controller. And the controller is just going to respond to a root request and say, welcome home, and give us the date. Good enough to get a hoodie with. So now we're going to go ahead and take it and deploy it to Cloud Foundry using STS. We also, of course, have a command line tool, VMC, which we'll show a little bit later as well. So in STS, I'm going to create a new server instance. So basically deployment is kind of the same as what you're familiar with if you've used Tomcat or any other kind of server within STS. So we're just going to create a new server. And we've got a Cloud Foundry type here. Okay. And we'll call it cf.com. Okay. So here I'm presented actually with a number of options when I'm creating the server as to which server I want to connect to. We're going to talk about that a little more, but Ramnivas alluded to the fact that you can run Cloud Foundry multiple places. And I'm actually running most of my demos from here on out on my microcloud. But for this one, we'll go ahead and push it to cf.com. So I just need to enter my credentials. Validate real quick. Okay, looks valid. So go ahead and finish that. So now I should be able to drag my Hello World application onto my Cloud Foundry server, which looks like it just refreshed, so let's try that again. Okay, so it pops up a dialog box just asking me some basic information for deployment, and the defaults look fine. So if you see here, we've got basically all of the web frameworks that we support as possibilities for deployment, but it has detected correctly that this is a Spring app. And then I could choose Java 6 or 7. 6 is fine. Okay. It's assigned me a URL by default, which I can change, and a memory reservation by default, which I can change, all of which looks good to me. And then if I wanted to create services or bind to existing services, I could do that here. This is a simple hello world, so we don't need to be storing any data or passing any messages. So I'll just click Finish. Okay. And should be going. Somebody took my URL already. Imagine that, hello world, already taken on cloudfoundry.com. Okay, luckily I can go here and edit my mapped URLs. So how about hello world, SpringOne, what's new? That can't possibly be taken. Okay, so we'll go ahead and change that, and then it'll restart here. So you can see down at the bottom, and I'll expand it once it starts up. The console output here is just showing me all the logs of the app that I just deployed. So I'm seeing that as deployed on cloudfoundry.com. And if I go back to my view here, I can actually hit the URL directly from Eclipse. And there's my hello world. So in just a few easy steps, created an application, got it deployed to Cloud Foundry, all from within my IDE. And like I said, we'll show you command line access as well. So there's a number of different options here, but this is just kind of the quick way to get started and get your hoodie at the booth. Okay. So back to the planned agenda. I'm going to walk through a number of things that have been new in Cloud Foundry, mostly just things we've done in the past 6 months has kind of been the cutoff. And there's a number of areas that we've touched on that I'll walk through that are shown here. I'm going to be taking you through frameworks and runtimes, some new stuff related to security and how accounts are managed on Cloud Foundry, new things in services and tools, and microcloud. And then Ramnivas will talk to you about the commercial offering that he alluded to in the beginning. So what's new in frameworks and runtimes? So as Ramnivas explained, these are the core runtimes and frameworks that we've pretty much supported since Cloud Foundry was created. I think Rack was a newer one, and Play is a new one. But for the most part, these are what we've been focused on and what's available on cf.com today. Now, if you're actually running Cloud Foundry yourself from our GitHub repositories, there's a number of community contributions that you can find in there as well. So we also do have Python and Erlang and PHP support. And then there's other partners who have added Perl and .NET that are running those on their infrastructure as well. You might have heard of some of our partners like AppFog for PHP or Staccato for Python. They're essentially running the Cloud Foundry code base, but with enhanced support for those particular languages. So when we're evaluating whether or not we want to actually offer support for a particular framework, we live by the platinum rule, as coined by Ramnivas. And essentially what this means is, we're looking at things about this framework that we can really do to enhance your experience on Cloud Foundry. One example is Node.js, for example. We will actually take a Node application and install all of your Node modules for you. We'll go download them from the Node site and install them. And basically, every framework, we have things that we do that are specialized to that framework that kind of help you out. Rails apps, we run database migrations, etc. And we'll see some of this as we go. But this is kind of what we look at when we think about whether or not we want to offer explicit support for a framework on Cloud Foundry. And when we do offer support for a framework, there's a number of things that we have kind of common that you'll find across all the frameworks that we're committed to providing you. So of course I mentioned command line for management. You can do all the things you need to do, like creating apps and services, scaling up and down, and updating service bindings, etc. And then we also provide access to information about services through environment variables that you can use in your app. But we like to take it one step further, and for most languages, our team has written libraries that you can use to programmatically access services. We'll show a little bit of that later, but we have that for Node, Ruby, and Java libraries that we've published to make that a little bit easier so you're not parsing JSON and environment variables yourself in order to connect to your cloud services. Ramnivas mentioned auto-reconfiguration in the beginning. This has been a really important area of focus for us. Basically for each of the frameworks, just trying to think about if you've got an existing application, and it's using, say, a local in-memory database, can you just push this out to Cloud Foundry without changing it at all? Is there a way that you can push this app out and it'll automatically be reconfigured to use a cloud MySQL service instead? In fact, I think we talked in depth about that at last year's SpringOne. We had a whole session that covered a lot of those things. Some of you guys may have been there for that. So that's another common thing that we like to do to make the experience easier for you on Cloud Foundry. Another is accessing services. So fairly recently, it's been before the 6-month cutoff, we introduced a way to tunnel to services called Caldecott. Basically, this allows you just to inspect the contents of your database, say, remotely, and use the tools that you're familiar with, like your local MySQL client, to do so. And I'll demo that for you guys. And lastly, we offer manifest support, which we'll also show. This is basically just a way to tell our command line tool in a file how to deploy the app so you're not constantly interacting and answering questions. So as Ramnivas said, we have a number of frameworks that we're providing. We're committed to providing more as the need arises. But there was definitely a category of applications that we weren't really supporting before. And in late spring, we actually introduced Standalone framework, which is kind of the no framework. And basically what this is, you package up a set of bits and you push it out to Cloud Foundry, tell us how to start it, tell us what runtime you want to use, and we'll run it for you. So we don't need to know a great deal about it. It doesn't have to be developed with a particular framework. And most importantly, for a lot of categories of apps, it doesn't need to be a web application. It could be a worker, that type of thing. And I'm actually doing an entire session showing all the different applications of this. That's the next session, if you're interested in seeing that in depth. So as I mentioned, there's a couple of common use cases for standalone applications. Worker processes are a good one. And then there's a set of frameworks that are kind of the new asynchronous lightweight web frameworks. A lot of them are in Scala that make use of Netty for non-blocking I/O. And those typically tend to be started with a main. You don't run them in a container. So we've kind of opened up to being able to support those types of frameworks as well. It's like Unfiltered and Spray. And I actually didn't ask, who's a Scala developer in here? Do we have any Scala guys? No? Yeah? Okay. So you might be familiar with some of these frameworks, and I'm actually going to demo Unfiltered so you can get a feel for it a little bit later. And then also Vertex, which is a newer offering it's a community offering, but it's done by someone who works with VMware, which is basically a Java framework that offers that similar highly concurrent model, similar to Node.js, but running on the JVM. And then, of course, also if you have certain frameworks that have a tendency to, embed Jetty, for example. Sometimes with the programming model, it's easier to have a main and actually start Jetty up yourself as opposed to packaging it as a war. So I think you guys get the idea. Basically, it's apps you don't have to package as war files. Just run them as standalone. And I'll be demoing that. So kind of walking through each of the language supports that we have now and talking specifically about what's new, starting with Scala. So previously we supported the Lift framework, and that included auto-reconfiguration for your database if you were using the Lift framework. But now we have explicit support for Play 2.0, which is another web framework for developing Java or Scala apps. Some of you may have heard of it even just for Java development. And then, of course, as I mentioned, a whole bunch of Scala frameworks that lend themselves well to the bring your own container approach. And through standalone support, also, we are able to do some work with akka. And I have an akka sample in my next talk if you're interested in seeing akka in action on Cloud Foundry. But switching specifically to Play framework, so basically we are now supporting Play 2.0. Pretty easy to push a Play app to Cloud Foundry, and when you do, there's a number of things that we'll do for you automatically. So Play supports the notion of evolutions, basically just SQL scripts for setting up your database. We'll apply those for you. We'll do some auto-reconfiguration, which I'm going to demo, to connect you to the proper cloud service. And then beyond that, for the relational databases, we offer a set of properties you can use in your config file that will also automatically connect you to other services like Mongo, Rabbit, Redis, etc. And then, as I mentioned before, we provide libraries typically called Cloud Foundry runtime that allow you to make programmatic service connections, which can be useful in a Play application as well if you don't do the configuration-based approach. Okay, so now we're actually going to do a demo just showing Play on Cloud Foundry. So I'm actually going to use the Zentasks sample that comes with Play, and I'll just open it up really briefly and kind of show you guys the anatomy of the Play application. So kind of the same things you're used to seeing, controllers, views, etc. This is a task management application. So for example, I could look at, say, a method for adding a project, and actually let me up the font on that one. Hopefully that's viewable in the back there. So I could look at a controller method for adding a new project for my task management, and it looks relatively straightforward. I'm returning an OK response, doing some stuff with the request bindings, etc. And Play, of course, is typically everything is created bootstrapped through command line interface, so you can create controllers and web apps and such through the command line interface. But let's take a look at the configuration. This is kind of what we're interested in from a Cloud Foundry perspective. So you can see here in the middle my database connection parameters. So I'm going to be connecting to a database to store my tasks and projects with the application. And you can see here that when I'm running locally, I'm going to be using an in-memory database. And like I said, this is an exact clone of the sample from Play without modification. So what's going to happen is we're going to push this to Cloud Foundry, and you can see here that we've got some evolutions to be applied. So when we push the app, it should create the tables and allow us to interact with the application automatically, and should connect us up to a Postgres service that we'll provision. So we'll do this one from the command line using VMC. So typically the way to build Play apps is with the play dist command. This builds a zip file of essentially all of the things that Play needs to run your application. Okay, so the application is ready. So I'm going to use VMC push to push the application. And in this case, since the app is not resident in the directory that I'm starting in, I'm going to actually give it a path. So here I'm pushing to a path with the Zentasks zip file that has everything I need. Okay, call it Zentasks. So it's asking me how many instances of Zentasks I want. So I mentioned before that with Cloud Foundry, scaling up or down is really easy. I could choose to have multiple instances of my web application running, in which case Cloud Foundry would load balance for me. I'm sure probably saw this in the boot camp. I think Josh tends to demo that. But right now we'll just go with one instance. I'll show scaling up a little bit later with some worker processes. Okay, so it's auto-detected that it's a Play application, although I could tell it otherwise, but that sounds good to me. And then it wants me to choose a runtime. We'll go with Java 6. Again, a URL. The default is fine, which I just accidentally. Okay. Default memory limit at 256, also okay with me. And then it asks me if I want to create services. So this is, of course, analogous to what you guys saw with the STS plugin. So in this case, I'll say yes, and I'll go with a Postgres service. We'll call it TaskDB. Okay. Don't want to create any other services. I'm good there. And then it asked me if I want to save the configuration. So if I answered yes, it would essentially write everything that I just did out to a manifest file, which I can then use to push the application later. And the next app that I push out, I'm going to have a manifest, so we'll go over that. So for now, I will not save the configuration. So now it's uploading to my cloud and starting up the application. So in a second, we should be able to get tasks, checking to make sure the application's up. Okay. And if we take a look at the logs first using the vmc logs command, we actually see here in the play output that we are in fact connected to the Postgres database, even though we didn't change the configuration otherwise. And so if we go to the URL and actually access the app, we should be able to work with it because the evolutions were applied. Hopefully. Browser's been a bit iffy since I connected the direct internet. It's funny that STS works though. I don't think so. Oh, right. Direct internet issues. Okay. Yeah, I'm plugged in. And it's fine, I have access. It's just for some reason my browser isn't wanting to hit the domain. I have access to the outside world. What is VMC app? What is VMC what? Apps. Yeah, no, I think the app is fine. It was doing this earlier too. It's fine. It should be accessible. We can just use this browser for now. See if this one does any better. Yeah, that'd be the other option. Sorry guys, one sec. Demo gods are not with me today. Okay, let's see if that one works. Okay, wireless for the win. All right, so now I've got my login screen here, just a minor delay. And we're going to go ahead and sign in and just verify that everything deployed successfully. Okay, and here we have our task dashboard. So that was basically a play application deployment in a nutshell. Moving on, since we lost a little time there. Okay, so we have a few things that we're thinking about for Scala support offering in the future. These are just things our team's kind of kicking around. We're definitely open to any ideas that anybody might have. I won't spend much time on them since we don't have Scala developers, many of Scala developers here at the moment. But definitely, take a look and offer suggestions. Similarly, we don't have a lot of Node developers in the house, but I'll just talk real briefly about what we've done with Node in the past 6 months. So previously we had both support for 0.4 and 0.6 versions of Node. We've recently added Node 0.8 as a runtime option. And we significantly enhanced and provided NPM support. So I mentioned this earlier, where basically if you're using a Node application and you specify your Node modules in what's called a shrink wrap file, which basically just fixes the versions of each of the Node modules that you're using, then we will download and install them for you if you don't have them packaged with your application. And similarly, that includes Git modules, which we just recently added support for. I don't even think we've announced that yet. And of course, for anybody familiar with Node, there are some modules that have native dependencies. So even if you've packaged those up with your app, we'll install them with the appropriate dependencies on Cloud Foundry for you. Okay. And of course, Node has auto-reconfiguration and runtime as well. This is another thing that we've added recently within the past 6 months. So we use kind of some common Node modules that everybody is using to connect to databases or messaging services, and we kind of automatically switch those out on deployment. And then we also offer a node module called cf-runtime for finer control over service connections. So if you wanted to kind of graduate and move away from using the automatic reconfiguration, there's a library for you to easily obtain references to clients if you want to connect to the cloud services yourself. Okay, not a lot planned for Node at the moment. I'm sure there's going to be more things coming up. Kind of daily we have ideas around that. But again, if anybody has anything, do let us know. Java. So basically, we've supported Spring, Grails, and other Java flavors of web apps. Basically, if it's in a war and it runs with Java 6, typically it was going to be fine on Cloud Foundry. And we offered actually quite a bit of auto-reconfiguration for Spring apps and Grails apps as well from the beginning. So of course we had what you guys saw with Play where you automatically get connected to the database. But we also have offered kind of a number of properties for Spring Free1 that we expose automatically that you can use with Spring Free1's property support. And if you're familiar with profiles, we also automatically will activate a cloud profile, and I'll show you guys this in a context later. So quite a bit of support for Spring in terms of making your experience easier there. And in the past 6 months, we've added Java 7, which I know a lot of people were happy about. And then, of course, we've added the standalone support, which has opened up some categories of interesting Java apps. Spring integration and batch. We're going to see a Spring integration sample soon. Mentioned Vertex already. You could package Tomcat 7 since we're not quite there yet. At the moment when you push a war using one of the Spring, Grails, or Java frameworks, it is deployed by Cloud Foundry onto a Tomcat 6 container. So for those people needing Servlet 3, we actually recently posted a blog on our community blog site showing how to package up Tomcat 7 yourself so you can get that deployed using the standalone support on Cloud Foundry. And actually, I think we also recently had a blog post showing some experimental support for Clojure, also using standalone apps. You can use it for running Groovy scripts, etc. Basically anything not a war in the Java world. Another thing that we blogged about, I think, within the past 6 months on cloudfoundry.com is JRuby support. So we didn't really necessarily do a lot to add support for JRuby. That was kind of already there. But we have done some documentation so you can see how to include JRuby in some applications that you might want to deploy. Okay, so now we're going to do another demo where we're running workers on Cloud Foundry with Spring. This is going to use Spring integration. This is actually a pretty interesting one, so hopefully the wireless holds up. The last time I demoed this, I didn't get the best part of it. So what we're going to show is actually a distributed application in 2 parts. One part is a worker that's powered almost exclusively by Spring integration. And what this worker does is it polls Twitter for tweets containing the word cloud and then essentially posts it to a RabbitMQ messaging solution. That's going to then get picked up by our front-end application, which is written in Node, and pushed from the server to the browser. So we'll see that going. So the first thing I want to show is the worker application. And like I said, it's almost exclusively written in XML using Spring integration concepts. Who's familiar with Spring integration? Okay, about half you guys. All right, good. I think even if you're not, it's pretty self-explanatory, which speaks a lot to the Spring integration domain and namespace. So basically what I have set up here in my XML file is a channel for searching Twitter. So you can see here that I've got my query for cloud. And I'm polling every 5 seconds Twitter. And this is all, just through Spring integration support. All this namespace stuff is provided by Spring integration. And then on the outbound channel, I'm using a Rabbit exchange called Tweets, and I'm publishing that tweet information to Rabbit to get picked up, in this case, by another front-end service. I mentioned earlier the concept of profiles. So basically, this kind of allows you in Spring, I think it's new Spring Free1, to have kind of different profiles for cloud or if you're running locally. So in this case, if I was going to run this app locally, I could have my own connection factory to a local AMQP instance. But if I switch to the cloud, I can use this cloud namespace to automatically create a connection to a RabbitMQ service that I provide. And this cloud namespace is provided by the Cloud Foundry runtime lib that I've mentioned several times now. So again, this is kind of our way of giving you, even better access to services. Aside from being able to programmatically do it in Java, we have Spring namespaces for you. So just with this one bean definition, I've created a connection to a cloud service. So because pretty much everything is defined here in XML, the only Java code I actually need is a small main So what the main's going to do is just check if we're running in Cloud Foundry, again using the Cloud Foundry runtime library. And if we are, it activates the cloud profile. Now, as I mentioned before, this happens automatically if you're pushing a Spring Web application, but for standalone, we don't really know what you're pushing. We just know it's bits and you're using Java. So you got to do this step yourself, at least for now. We have contemplated ways to do auto-reconfig of standalone Spring applications. So basically, I'm just going to activate the cloud profile, load up the application context in the main, and that's going to be pretty much it. So we'll go ahead and push this, again, using the command line this time. Okay, and let me grab my notes because I do tend to forget the start command, which is why it's good to have manifests. Okay. So I also didn't show the POM file here, but it is worth noting that basically we're using the Maven app assembler plugin. And what that'll do is provide kind of a distribution directory. So again, you can easily push to Cloud Foundry. It creates a start script for you, and then, there we go, app assembler. Creates a start script for you, and then packages all of your libs into a single directory. And this is the configuration in Maven for that, so I'm telling it the main class to execute in the start script. So if I was to run Maven package, which I've already done, then you can see here I've got in target app assembler both a start script and then the repo directory which has all of my dependencies. And if I look at the actual demo script, it just launches Java with Java ops, sets up the class path, etc. So all that can be done by Maven package using the app assembler. Yeah?
That POM file, is that created by you creating a special type of a project?
I actually think that there are, not in particular, but there are templates. Oh, I'm sorry. The question was the POM file created by my using a template project? And I do believe that we do set up for some of the template projects dependencies. I didn't use it for this particular one, but we do have a Spring integration template, don't we? Yeah. And it would have, yeah. Now, I don't think it would have included the app assembler plugin itself. We don't have anything for that, but most of the dependencies and such would have been set up. Okay, so I'm going to use VMC again. This is the last time that I'll do it with the interactive. So in this case, I'm going to give it the path to the app assembler directory that I just showed you. Okay, we'll name it Twitter to Rabbit. One instance for now. And this time it's asking me pretty much all of the available frameworks. What do I want? I'm going to choose Standalone. We'll use a Java 6 runtime. And then my startup command is simply just a reference to that script that was created by the app assembler plugin. So just bin demo. Okay. And in this case, I don't actually need a URL. So its default for standalone applications is none. You can certainly provide it a URL if you're doing any type of web application that I mentioned before where you bring your own container. But in this case, I don't need it. Let's give it 256 megs of RAM. And we're going to create a Rabbit service to bind it to, named Twitter Rabbit. Okay. So again, just going through, don't need any other services, won't save the configuration for now. So this will start up our worker process, and it should be out, hopefully pulling for tweets if our wireless connection is held up. So then the second part of the distributed application is the web front end that I mentioned. And this is a Node.js application that uses sock.js to allow for the server to push notifications to the browser. I'm going to go in more depth about that actually in my next talk as well if you're interested in that. But I'll just real briefly show you the structure of the application. Oops. So I mentioned before for the Node applications, the npm shrink wrap file, probably not as familiar to you if you're not familiar with Node, but basically this is just a listing of all the dependencies and their versions, so similar to a POM in the Java world, that Cloud Foundry will use to make sure everything is packaged up correctly if I don't build the Node modules myself, which in this case I actually haven't. And then this time I'm actually going to use a manifest that was created from a previous interaction with VMC. So you can see here, it's basically all of the answers to the various questions you've seen me provide. What's your framework? What's your runtime? How much memory? What's the URL? Etc. And this is basically just going to allow me to do VMC push, and it'll push the application out. Binds it to the shared Rabbit service. so that it can consume the tweets off of the queue as they're pushed on by the worker. So once we open up a browser, we should hopefully get some tweets going. Okay. So in a few seconds, if internet is working correctly, we should start to see tweets appear on the screen being pushed by the server to the client. There they are, yay. And actually similar to Mark, a lot of times I get some pretty obscene stuff when I do this, because cloud, I guess, is not really a specific enough search item to guarantee technical content. In this case, yeah, I don't actually see a lot of very technical cloud things. But you can see here as it polls, it receives the messages from RabbitMQ and then pushes out to my client via the Node.js and sock.js application. So that's just kind of one example of what you can do with standalone apps now, and kind of the world that it's opened up in terms of distributed support and support for workers. Okay, so as I mentioned, we are thinking about ways to provide that auto-reconfiguration for standalone Spring apps right now. We also have a blob service that's relatively new that we're considering providing support for. And of course, we do want to eventually allow you to choose Tomcat 7 when you push a war, so we're thinking about doing that and other things as well. How we doing on time? Okay. And just to kind of sum it up, these are some general things that we're thinking about doing right now, and actually have started the work for some of this. So we do want a way to be able to push more runtimes out more frequently. So right now, we have kind of the same fixed amount of runtimes that we've always had, and we do tend to add new versions, but it's a little slower than we would like it to be. So of course we're looking at announcing a deprecation policy. Node 04 has been on for a long time and is rarely used anymore, so that's one that's probably a candidate for deprecation. But of course we're not just going to remove a runtime without an official way to tell you and give you a chance to move off of it, etc. Similarly, we're looking at automatic upgrades. So for patch versions or things on like a very minor release, if you deploy to Cloud Foundry, we can automatically upgrade your app when a new version is available for you. And then, of course, I mentioned more frequent additions of runtimes and new versions as well. Another thing we're looking at doing is serving static assets directly from nginx. So right now, for example, in Rails, if you have a bunch of static assets, those are actually served through the web application. So we have to essentially route traffic all the way through to your web app to serve those up. So for an enhancement, we are looking at doing that directly from nginx instead. And the bottom one is a minor thing, but if you've ever tried to write to a tempdir in any of your Cloud Foundry apps, it's relevant for you. We do now have a consistent temporary directory structure for all applications, and the environment variable is set as such. And actually, I think that's already been done. So that kind of covers frameworks and runtimes, and that's sort of, I guess, the meat of what we wanted to talk about, some of the more interesting user-facing features. But to now dig a little deeper into the architecture. So for those who aren't familiar with the Cloud Foundry architecture, Ramnivas is going to be doing an in-depth talk about it later on today. But the Cloud Controller is just sort of our main component that essentially is the REST endpoint for any client connections that you make. So VMC is talking to the Cloud Controller, STS is talking to the Cloud Controller. That's essentially what you're talking to if you're interacting with the system. And we are rewriting it, have been for a little while now. There's been a few blogs about it. The branch, of course, is out for everyone to see on GitHub. But the new rewrite is switching from Rails to Sinatra, which makes a little bit more sense for a web application that doesn't have a front end and it's just handling REST services. And we're putting a focus on the RESTful interaction, kind of reducing round trips by giving you the ability to get information that you need more readily available depending on the parameters that you passed in. And of course, there's also a rewrite for some new features that Ramnivas is going to talk about as well. But these are kind of some of the architectural concerns. Similarly, the DEA is called the Droplet Execution Agent, and this is essentially the component that runs your application on Cloud Foundry. It's undergoing a rewrite as well, and basically what's happening right now is it's using a new component called Warden, which provides a container for app execution. So you can see right now on the left-hand side, basically your apps are running as secure users on a DEA. And what Warden's going to do is essentially give it a container using Linux control groups, where it'll have essentially its own private network, file system. We'll be able to isolate resources, so CPU usage, memory usage, etc., using this Warden container. That's also, of course, available for everybody to review on GitHub, and there are some people who are using it locally in their own setups already, kicking the tires with that. And it was actually, they did consider using LXC, for those familiar with the Linux containers, but basically this is kind of an abstraction a little bit higher level than that, so you can still interact with the container API and do the things that you need to do while switching out the underlying implementation. And so this is how they chose to implement it, as opposed to the individual commands of LXC. So this should open up quite a few possibilities once this is actually deployed and fully integrated into .com. And another big component that we've been talking about on the blogs lately is the UAA. So this is our centralized account and authentication piece. And it's, I think, the one bit of Cloud Foundry that's built with Spring, aside from our tools and such. But Cloud Foundry is predominantly a Ruby application. But the UAA is a Spring web app running with Spring Security. It's an OAuth 2 provider, and basically this is going to kind of open up the door for a number of things you can do with your own web application if you need to accept credentials. So it's offering kind of a place for centralized identity management, one place to hold all of the authentication information. And of course, single sign-on is a possibility as well. So if you're providing an app and you just want to take credentials, why not take the Cloud Foundry credentials? It's also going to have a provider framework, or already has a provider framework. So if you want to do things like authenticate with a social network, that's something that the UAA is going to be able to offer you. And then, of course, account management, so you have a nice, solid REST endpoint for doing all the things you need to do to provision an account, delete account, those types of things. And right now, I believe, if you want to register your own client applications to act with the OAuth server, it's something that has to be done via email, but they are working on basically UI tools so that you can go to a website and say, I've got this application I want to run on Cloud Foundry. I want it to accept credentials. Register me and allow me to do that. Okay, that brings us to our next category, which is services. Okay. So you guys kind of saw the list of services that are available on cloudfoundry.com right now as I was doing the push, and these have been around for quite some time. We have MySQL and Postgres for relational database, Mongo and Redis for NoSQL, and then, of course, RabbitMQ for messaging. We also have a number of other services that are available in the open source code base. So again, if you're deploying yourself using what we call dev setup, which is basically just a way to get Cloud Foundry installed onto a pristine Ubuntu VM. It's kind of how we all work with Cloud Foundry on the engineering team. Then you actually have access to all of these services as well that are in the open source code base. And I think the new ones within the past 6 months, Elasticsearch I know is fairly new. The blob store is fairly new. I mentioned that one earlier. And I believe Memcached is fairly new as well. And people are developing services kind of all the time. I think somebody had just asked me at the booth about how to develop a service. There's a document on our OSS docs that describes how to develop your own service and register it with the service broker if you're interested in providing that as well. And of course, if you'd like to contribute it back to us, I'm sure we'd like to have it. So just in terms of services in general, what are some of the things that we're providing and going to be providing? So of course, right now on cf.com, we back up your data. It'd be pretty bad if we didn't. And that is something that is invisible to you right now. So of course it's happening, and of course, we could restore a certain amount of data if something were to go wrong, but you don't, as a user, have any control over that. So one thing that we're going to be adding is a user visible snapshot feature. So this is going to be able to allow you to, take a snapshot of your data at any point in time, download it, look through it, maybe even upload your own snapshot to replace the current data. And that's something that's going to be coming soon that the services team is working on as well. Okay, and I mentioned Warden and its uses within applications. This is going to be important for services as well. So basically getting those services more contained into a sandbox to protect from the inherent security flaws that service might have. We hope that they don't, but better to secure them even more tightly. And the base library for services is going to make it kind of easy to wardenize new services. So as you develop services, there'll be a way for you to run them inside these secure containers as well. And then lastly, they've just introduced support for multiple versions of a service. So previously, we basically were just always on a fixed version. And now we have support for choosing between services. For example, they just started offering Mongo 2.0, and we already had 1.8. And actually, I think the work is in progress on the client side to allow you to choose between the two, but that infrastructure is already on .com. So we do have both instances running. And pretty soon you'll be able to choose between the two of them. And Ramnivas is actually going to talk about services a little bit more when he just goes over our commercial support that we're adding. Tools. Okay. So those who might have used VMC before may have noticed that the VMC that I was using looked different. So we do have a VMC NG, which is our next generation client, and it's undergone kind of a lot of interaction and architecture improvements. Hopefully the interaction improvements were obvious if you've used the two before just watching me use it. You can try it out for yourself. VMC is just a gem. I don't think I actually mentioned that earlier. So to get the VMC command line client installed, it's just gem install VMC. If you add a -- pre-flag, you get our beta, which is VMC NG. And you do need one additional step to actually use NG. If you download the beta version and you don't make this fake directory or file, it will continue to have you use the current version as opposed to the cutting edge version. So if you're interested in getting cutting edge, you can evaluate. Let us know how you like it. So some of the things that we've done to improve interaction, our questions are less verbose. Pretty obvious thing, but good to have. Tab completion. Rewinding is actually one of my favorite features, and I probably didn't catch it, but I used it, I think, in one of the previous demos. So basically, if you're in a question, say in this particular example, and I think I used this for URL, if you're in a question and you realized you answered, say, runtime wrong, you can actually hit the up arrow, go back to that question, re-enter, and then continue forward. We're also offering better scripting support, so I'll talk a little bit about architecturally what needed to happen for that to transpire, but basically it's now significantly easier to script your interactions. And of course better progress indicators. If you've used the old VMC, you don't get quite as much feedback on what's going on as you do with the new client. And architecturally, it's made us much happier as engineers to work with it. So we've kind of separated out a lot of the actual interaction logic from the library that interacts with the Cloud Controller API. So basically, we have what we call cf-runtime gem now, which is something that you can also use yourself, which provides an object layer in Ruby instead of parsed JSON. So interacting with it, I'm dealing with apps and services as objects as opposed to giant requests or responses that I have to parse from the client, which makes it nice. And this kind of allows us to keep our small core, nice and clean. And then we also have a plugin architecture for extensions, which further allows us not to pollute the code base. So you can add extensions, and we have a couple already for tunneling, and then the manifest plugin is an actual extension. So everything that VMC does that interacts with the manifest file is done as a plugin, and those are automatically loaded if they have a certain naming structure by the core VMC. There's some new things in STS plugin. So of course before you could deploy and debug all your various Java web applications, but now you can deploy and debug standalone applications, which I'll show you guys. And then you can also open up tunnels. So as I mentioned before, the tunneling support allows you to interact directly with Cloud Foundry services using your favorite clients. That's now something that you can do from STS as well as from the command line. Okay, so last demo, I think, of the talk. We're going to deploy a standalone application using STS. So the application I've chosen is actually a Scala app, and it's using the unfiltered framework that I mentioned earlier. So we'll just explore a little bit about what it's doing. So basically the interesting thing here is the bit that starts up the embedded Jetty. So using unfiltered framework, this is kind of the main and how we get started with that. So you can see here that we're actually creating a server, and we're using the vcap app port environment variable. So that's available so that you know which port to bind to. It's important for pretty much anything that you're doing that's bring your own container like. And then of course if we don't have that environment variable set, we just use 8080 for local development, so this should work in both places. So yeah, this is basically just our little main that kind of gets the whole web server up and running. And then if we want to take a look a little bit closer at what some of this application does, this app is actually, it was developed by a New York Scala experience group, and it's an image processing server. So we took it and enhanced it to work on Cloud Foundry, which didn't involve much. So basically just the bit that you saw to bind to the proper port. And then also we had to bind it to the appropriate Mongo instance. So this application stores all of the images in gridfs in Mongo that it processes. So again, we're using that Cloud Foundry and runtime lib. This time we're using it programmatically since we're within a Scala application. So we basically added here, it just goes out, it finds any information it can on any Mongo services that are bound to my application. And if it finds one, then it creates that Mongo connection using the data, so the host, port, username, etc. And we're going to work with that. If it doesn't find one, it connects to this particular server, which I was shocked to find out a couple weeks ago they actually had a valid username and password for. The Mongo, I'm actually not sure whose server this was, but I was pushing images to it, which was pretty interesting. So they might have a couple images that they weren't expecting on their Mongo server. I did since change the password so I wouldn't accidentally do that again. So at any rate, we're running on Cloud Foundry. We're going to bind it to a Mongo service, so no danger of using the wrong server here anyway. So that's kind of it for the explanation of the application. Since it is Scala and unfiltered, kind of a lot to cover. I am going to go a little bit more in depth on this in my next talk as well. But what I want to show right now is just it deploying and running on Cloud Foundry. So for the standalone app support, there is one thing that you have to do to get it to work with WTP in Eclipse. And then configure, there's a menu item that'll say enable as a standalone app. One-time operation, do it, you're done. As long as you've got the app there. Yeah, so it's under configure, and it would say enable as Cloud Foundry standalone app. In this case, I've already done it. So, and I'm not sure how much memory allocation I have, so I'm going to delete these guys. So I'm going to delete all the applications I've pushed thus far and the services using STS. And it's asking me here if I want to delete orphan services, which I do. Okay. So now we should be able to drag our bit show application here to the server. And you can see from the first screen, it actually would have let me choose between Java 6 or Java 7. Java 6 is fine here. So this screen's a little different since it's a standalone application. It's asking me a few things. One is the URL, and in this case, because this is a web app with embedded Jetty, I do want to give it a URL. We'll call it BitShow. Okay. Memory reservation is familiar. We saw that with the web applications. And then here, basically, it wants to know the name of a Java main to run. So essentially, STS is going to take all the class files and all the dependencies from the build path, and it's going to push those out to Cloud Foundry automatically for me. It's set up a command line here, which uses a small class path that essentially has the libdir with all of my dependencies and my classes. So this is nice because I don't have to worry about using something like Maven App Assembler to package up my application into a distribution. STS is just going to put everything where it needs to be automatically. All I need to do is provide it a main. If this were a Java app, it would automatically detect it. We don't yet have automatic detection for Scala mains, but I heard it's coming soon. So I'm going to type in bitshow.server, which is the name of our class that contains that main that will launch Jetty and get our application going. Next up, services. So this time I do want to add a service. Let's go call it image store Mongo. Okay. And now I'm ready to deploy to Cloud Foundry. So off it goes. Okay, so we should see the console information coming up shortly. Doesn't really tell us much, but we know the application's running. So let's go ahead and visit it. Okay. So here I'm running the BitShow. Not much to see yet, but let's go ahead and upload an image and play around with it. So I've got this image of a bear. I don't know why I chose a bear. It just looked interesting. Okay, so we're going to post the image up to the server. And then there's a little combo box here that lets us do interesting things with the bear. Let's flip him over. Okay, so the bear is flipped over. And this actually uses image magic underneath. If you're familiar with image magic, that's actually something we've also added fairly recently to Cloud Foundry as well. So pretty much any application in any language that needs to use image magic for processing, it's now available on the path for you to use. So if we go back to the logs, we can see here that we've been saving a couple of files. So we saved the bear when it was uploaded, and we saved the flipped image to gridfs in Mongo. So if I wanted to actually open up a tunnel and just look at the Mongo contents myself using the Mongo command line tools, I can do that from here. So if I access the service here in my list with STS, I can right-click and open up a tunnel. And what this is actually doing is it's binding my service to an application that's deployed called Caldecott. So if I didn't have this application already deployed, it would deploy it for me. Just kind of a heads up, when you're using tunneling, you will see a Caldecott application deployed under your app space. And basically this just handles all the tunneling of communications via HTTP. So it's created that tunnel for me, and it's given me the information. If I had a good Mongo client for STS itself, this would be pretty handy from that perspective as well, because then I could just use it right here without ever leaving my IDE. But in this case, I'm going to go to the command line just to use the Mongo files command line tool. And this one I definitely have to look up. So in this case, I'm going to use Mongo files, and I'm going to pass it a port. So it's opened up this local port, which STS has told me about, 10100. So I'll specify that. Then, of course, I have to provide credentials. And these are listed here, and I can right-click and copy them. So I'll copy username. And password. And of course, I could tunnel from the command line as well. I just wanted to show off the STS support in this particular use case. Okay. Lastly, the DB, and then I'll tell it to list. So basically, I just use the Mongo files tool, which has a number of commands. I use list. So here it's listing my 2 demo images that were put into Mongo. So verified that they're really there and we weren't making up the gridfs file storage. But that's just kind of one example of how you might want to browse your various data or messaging services to kind of get a peek at what's going on. Let's see. Okay. Doing pretty well on time here. I am just about done with my portion. Yeah.
Before you go off of that, I want to make sure I understood. I think you said that the image magic stuff was already included on Cloud Foundry, so that wasn't part of the standalone package.
Correct. Correct. Yeah, so the question was, is image magic already included on Cloud Foundry and not part of the standalone application? And the answer is yes. It's just installed for your app and automatically on the path, so you should just be able to use it.
So the following question there is, where can I find the definitive list of such things that are included in Cloud Foundry that I know I can leverage that aren't services but are things that it just finds out?
Right, good question. The question is, where do you find this list of things that are provided for your application beyond just services, but just general runtime information? And that's a good question. I mean, we do have, I think for each of the runtimes and frameworks on I believe it's cloudfoundry.com that has the document, or cloudfoundry.org that has the documentation. And it goes through tutorial-wise, walks you through, but I don't know that there is one definitive list that says these are the tools that we have available. Andy looks like he might know.
I don't know the answer, but I know that so a lot of this stuff, because we're incrementally enhancing.com, which is what Jen and Ramnivas are talking about, a lot of this stuff gets included on the blog, and so we're doing our best to make sure that gets integrated into documentation as we move along. So everything on cloudfoundry.com should be the canonical source, but sometimes there's a bit of cross-reference that needs to occur, so we're doing our best and pulling that information along as we go.
Yeah, so and to summarize Andy's answer, docs.cloudfoundry.com is the official place for documentation, and they are trying to keep up with the pace of our blogs. We typically, anytime we release something new, we try to blog about it on blog.cloudfoundry.com. If it's minor, we might just tweet it, so following us on Twitter is also a good way to go, but there is an initiative to get that stuff incorporated into the online documentation faster. Okay, so just a few more tools to mention in the tools section. We have a client library for interacting with the REST API. So if you wanted to write your own clients, similar to the STS plugin or VMC, we provide a jar, Cloud Foundry client lib in the Maven repository. I believe it's in the Spring milestone repository, where provides nice object support for interacting with our REST API. We have Maven and Gradle plugins, so you can do things like deploy to Cloud Foundry from within Maven or Gradle. Also, if you wanted to create your own client that interacts with tunneling, we've also published the library that's used for that as well, that STS uses for that. And of course, I've mentioned several times now the Cloud Foundry runtime jar with the programmatic service access. Also access to host import information, which I don't think I mentioned. And if you're using Node, there's the cf-runtime module, which offers the equivalent support. So last thing in my section is really quick look at what's new in microcloud. So you might have noticed from my URL that I was not using .com for some of my demos. I was in fact using microcloud. And what microcloud is basically a VM image that you can download from our website that allows you basically just to, if you've got Fusion on your Mac or Workstation on Windows, you fire up the VM and you have a complete running instance of Cloud Foundry. And it has not been up to date as we would like. So that if you go and download it from it now, you won't have a lot of the features that we talked about right now. But we are putting out a new release very soon that's up to date with latestcf.com. And we're working on a way to have more frequent releases so this doesn't happen again. And then, of course, an update mechanism for existing VMs. And a new REST API for configuration management. Who here is familiar with microcloud? Seen it or? Okay. About half of you guys. So I can show you really quick, not much to see really, but this is kind of the basic microcloud VM, so it just contains a number of menu items. The one that makes it really interesting for demoing is the offline mode. So I'm able to put this in offline mode, and if I lose internet connectivity, I can still actually push applications back and forth from my client Mac to this particular VM. So of course you can do, configuring your domain and then those types of network service things. And also because it provides the IP here at the top, you could SSH into it from your local Mac and look at the logs, do whatever kind of playing around or configuration you want to do on Cloud Foundry for yourself. Okay. And with that, I'm going to turn it back over to Ramnivas to close this out.
All right, so one thing I would like to say is, we got a lot of feedback from existing Cloud Foundry developers and users, and that's basically what makes us do what's new. So for the next SpringOne, what should be the new things we should be adding? You can, of course, give us feedback here, right? So after this talk, Jennifer and I and other Cloud Foundry developers will be hanging either near the booth or near the lab. So come talk to us. All right, so I want to round this out, this section out with talking about commercial availability on Cloud Foundry. We are working pretty steadily towards making this possible, and so it's going to come out of beta soon. We don't have a date yet, but it will be soon. And the idea there is we are going to target first self-sufficient teams of 3 to 20 people, and it's designed for collaborative operation. So right now, if you are on cloudfoundry.com, you can push your application, you can have your services, but you are in a sort of isolated world. So if Jennifer and I want to collaborate, there is no real easy way to. She has to give her password to me, and that's not a good way to communicate. So what we are doing now is we are basically providing a collaboration model where you can have teams, and teams themselves can be further segregated by what we call spaces. I'll talk about it a bit more. We also have going to provide paid tiers. So the idea here is by default right now you get some memory and a few services and some storage. But what if you want your application is such that it requires more memory? And if you're ready to pay for it, then we will give you a simple way to provide. You swipe your credit card and you start to get more memory. We will retain free tier, so that's not going away. So if you want to go and come to Cloud Foundry, try your some Hello World applications, you will be able to do essentially what you're doing now. Sign up if you haven't already signed up, because some of the first existing users are likely to get some preferential treatment when we invite people onto beta. It's going to be the best place to deploy your Spring and Grails application. We support all sorts of applications, but clearly, given our Spring source background, these are something where we take it far more seriously. So the theme for commercial availability is create, collaborate, and control. So we are offering a web-based portal in addition to STS and VMC, where some of your team members may not want to be comfortable with their tools. So they can go to web portal, look at what are the applications being deployed, what are the services being deployed, what are the tiers chosen for those, and change if they need to. We're also giving collaboration capabilities, so you can form teams around your project and stages of project. And finally, you get a cost control. So you may say you have certain spending limit, and if you reach near that, you may get alerted, and you can act on it appropriately by either changing the set limit or changing your memory requirements. So this is the web-based portal. Here you can create teams and assign roles to individuals. You can also manage your application instances. So if you get an alert saying your application is not responding as well, you can come here, change the number of instances, and that essentially has the same effect as you would if you were to do it from VMC. You can provision a catalog of services, and we are going to increase that. So not only you get the services that we made you available, but there are two other kind of things we're adding. One, third-party services that can be provisioned from the portal, and the services that we offer, you can choose various plans, which essentially are related to quota. And you can look at this is work in progress. It's changing pretty much every week. You can audit events and look at activities, so who did what when, and if your application is in certain state, you will get alerted here. So the collaboration model is you have an organization. It's a little bit similar to what GitHub has, except we tailored it quite heavily for application related activities as opposed to repositories. So you have an organization. Organization is bound to an account. An account is where the whole bill pay and everything occurs. And each organization has spaces. And here we're looking at three kinds of spaces, but you can segregate however you want it. There are some development space. So each individual member in your team can get a space. So here is a John space and Mary's space. And the idea is when you are developing an application, you are going to push that application to your own space. So you will have your own set of services, your own set of applications, and you work on it, you test it, and refactor and keep going through the development process there. When John is working on it, it's completely segregated from Mary's. So they both are working on their own individual version of applications, and whatever features they are, it's appropriate for individual one. When it's all done, so you reach a certain threshold at which the application is all in a shape where it can be given to QA, you can take that application and deploy it to the QA space. It is likely that here John's and Mary's is likely to work in free quota if that works out for them. But QA space may have some paid versions, so you may need a bit more memory, maybe more storage space for services. And here QA guys will come, test that application, and again it's segregated from John's and Mary's space. When that is done, you can transfer application to production. And here likely to have even higher quota, more memory requirements and so on. So you can take this application from one stage to other stage while still staying in the organization. Each space is going to have a bunch of developers, possibly, and they can therefore share those services, share those applications. You don't need to really exchange your password for that. The collaboration model, other way to look at is organization contains users and organization contains spaces. And users and spaces are connected through set of permissions. So there may be some users with manager permission, some user with only bill pay permission, And bill pay, that means you can't change your application or you can't change your services, but you can just pay. You get the privilege to pay. With manager, you can do some more things, such as you can change number of applications and you can manage other users. So you can invite users to organization. You can invite users to spaces. And each space contains application and services, and they can be bound through normal mechanism. So from the VMC point of view, this is how you look at it. So when you are, right now when you say VMC target, you give an API endpoint for the cloud controller. Now you can specify also some additional specifications. So in this case, you are specifying staging by giving -s. So you are saying VMC target, a specific URL, -s, a specific space. Or you can target to specific org. So essentially you can look at cloud plus organization plus space as an extended target. And when you target to that, that's where you're going to work with. Then you also have cost management, so you can manage your spending and resource consumption. So you can say, all right, this is all I can budget for a particular month or particular year. And you can configure your alerting, saying if I reach 90% of the threshold, then do the following things. When you need more memory, so in this case you specify that you need more memory through plan. I say memory, but there are a bunch of other things. So for example, you can choose maximum concurrent connections for database. You can decide what are the timeouts that you want to accept. Based on all these things, we offer a set number of plans. So for example, when you create a VMC service, MySQL, you can specify -- plan and choose one of the plan. This is of course available through portal and STS. And the service gateway, this is something I will talk about in my architecture talk, is going to route provisioning based on the plan. So for example, you may choose to have single tenant instance. Right now in cloudfoundry.com, all your services are on a shared host. And we segregate it, so there is no risk of your data being seen by others. Yet, some for compliance requirements or for just to have certain quality of services, you might prefer to have single tenant instance. If so, then you can provide a plan that offers you single tenant service. The idea here is you have now a platform that grows with you. You can start small. So if you're a startup, you might actually, if you have an idea, you can just start with a free quota, free plan, and simply prove that your idea works. When you're ready to grow, you can buy a small plan, and then you can choose that way. Choose that plan. When it's proven further, and when you're really launching, you can actually buy one of the biggest plan, and then that's where you can sort of stay on the same platform, but grow it according to your needs. So with that, we are ready to take some questions. And stay connected. If at SpringOne itself, you can stop by the booth or the lounge, attend Cloud Foundry session. So Jennifer is giving talk on standalone application. She has a bunch of demos there. Should be pretty interesting. After that, I'm giving a talk on Cloud Foundry architecture. So it's basically perspective from the inside out. And I'm also looking at as a tips for your application to essentially draw upon our experience and how basically how would you create a distributed application. So there will be some interesting tips there. Take the app challenge. So there's information pretty much on every seat. So you can take the app challenge, and there are interesting prizes. So hopefully you can win some. One of the all the resources blog is, if you go to the Cloud Foundry blog, then you will keep up with all the new features that we add. If you are interested in the open source aspect of it, the GitHub is the place to go. All right. So any questions? Yes.
How many of those features you showed that are coming soon in CloudFoundry.com are going to make it into open source? For example, is there going to be a generic UI potentially?
Sorry, what? Generic?
A generic website, make it into open source, or the spaces concept, the plans, are those going to make it into open source?
So the question is, I showed a bunch of features, orgs and spaces, collaboration model, as well as portal, of which one are going to make it into open source. Spaces and org, definitely. In fact, right now you can look at it. It's on a branch in GitHub. If you go to GitHub, there's a branch, and on branch you can see Cloud Controller NG has spaces and org model. That's already open sourced, and we are developing it open already. Similarly, all the things that Jennifer talked about, like DA-ng, the Warden container, they are again in open source right now available. Portal, we are not starting it as open source because it's not very clear what are the requirements. If you are on a small cloud, for example, let's say suppose you have, I don't know, 10 machines, and you're not really looking for billing or other things, then the requirement for that portal will be very simple than, let's say, if you want to go for a public cloud. So we are kind of waiting on that. So if there is a requirement that we can sort of zone on, then we can probably offer that as open source as well. Yes.
Are these slides going to be available? Right now they're not available.
Yes, they will be available. And even the question is, are the slides going to be available? Yes, they are going to be available. And I believe, in fact, the talk will be available soon on infoq.com as well. Any other question? Yes. So the question is there any work being done on Gemfire as a service? Not that I know of. We talked about it at some point, but there is a possibility that we keep talking about it, and it's actually not that difficult to do it. As in, if you want to do it in your own private cloud, all you have to do is write a service gateway and service node. And there are examples of how to do it for a bunch of services that Jennifer showed in the open source part of it. But if that is of your interest, definitely talk to us, and we will gauge that interest, and based on that, we'll act on it. All right. All right. So, yeah, take it. And a bigger point there is, I think I mentioned earlier, like we take the openness message to heart. That means we do really want to work with you guys, and somebody wants to provide a new framework. In fact, I don't know his old sound. I know his Twitter handle. I forgot his name. He works for VMware, but still, he wanted to provide support for Clojure. And what does he do? Well, he provides support for Clojure. So and then he can collaborate with us, and we can take that make it part of open source. You can make a pull request, review request really. So that's how you can grow this platform. Yes.
So you showed a slide way back when about the services that are in Cloud Foundry natively, and then the services that have been added by partners. Is there any difference in the capabilities on one of those two classes of services, or is it pretty much across the board? It doesn't matter whether it's been added by a partner or whether it's been part of natively part of Cloud Foundry.
Yeah, the question is, there are two classes of services. One class where it's natively available, like MySQL, Postgres, RabbitMQ, Mongo, and Redis at this point. And there are a bunch of other services available, such as Memcache. And so right now, there's a fair bit of difference. So the services that are third party aren't exactly available on cloudfoundry.com. It will be available in your own cloud if you want to start one. Over time, those services will be available as a third-party services that you can buy into. At that point, the difference between Cloud Foundry services and third-party services would be pretty much only as far as the billing payment and whatever availability requirements that you may have, but fundamentally no technical difference between the two.
So architecturally, there's no difference. One of them doesn't have any kind of special, works differently in a different container or anything like that. That part, architecturally, they're the same.
So question is there architectural difference? Yes and no. There can be difference. So there are two parts of architecture. One is there's a gateway and node, service gateway and service node. That concept will remain same no matter what kind of service it is. The node itself, however, may have that service running outside somewhere. So for example, you could have SendGrid service running in their own data center. and just it's connecting from here. So from application's point of view, it's local service. From application's point of view, there is no difference. But in reality, you may be going across network and go somewhere else. That part will be different, possibly, but not always. Any other question? All right, thank you very much.